What is up, YouTube? All right. Shall not be infringed. Barking Madly and Bison Hawk 1 are doing a video series on creating a windmill electricity generator. Shall Not Be Infringed has this hard drive platter on a bearing surface, and I've noticed that he has some donuts on there with the coil windings, and he's got some magnets on the deal, and it's cool. I've been watching their series with just sort of, I'm not gonna say mild interest, but I've checked it out. I don't know. I'm not gonna say speak so highly of myself, but I'm not really sure. Maybe in passing, like, oh hey man, I'm sure Lamb Dog would be known about it, and da 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 da. Yeah, I do. I do know about it, and I'm not exaggerating when I tell you that there's very little that I couldn't do as it pertains to generating and utilizing electricity. It is the specialization that I had chose to take the last couple of years based on where I think the automotive industry is going. However, that same specialization has ended up actually screwing me as the business goes. So, whenever we go to training and stuff, they ask like, "Hey guys, what's your specialty?" People will be, there'll be a trainee guy or a suspension guy or whatever. And I was a drivability electric, and I've since actually considered my specialty to be hybrid and electric propulsion, but it's not actually a specialty just yet, as far as social description goes. But I've studied and learned as much as has been available to me as it's come along the way. And that even goes back way back to my time at the University of South Florida, where they had an electric powered S10. That was one of the old style where all the wet cell batteries were in the back, and they had this solar panel thing, and it was actually sponsored. They had Florida Power, which is an electric company down here, was one of the main sponsors of that vehicle. I'd always been very excited. Even when I was college bound, I was always very excited with the proposition of multiple source energy. As a bit of an aside, the reason why we've stuck with the internal combustion for so long, and I was going to do a video on this all by itself, and I may still, it has to do with energy transfer. We can take let's say you have a cubic foot of gasoline, the amount of energy that's in a cubic foot of gasoline and the way that it can be transferred in an internal combustion engine is still light years ahead of our ability to capture and transfer energy otherwise. The energy that's lost now, it's quite a bit less than it was 20 years ago when we were sitting in front of that S10 and hooking an electric motor up the size of a beer keg. That thing was a beast, though. It was very powerful. Between the batteries and the motor, the loss was very great, and it's much less. And the technology has developed to simplify that. The technology of efficient energy storage has simplified. But you still have that issue of transfer. And with petroleum products, the transfer is sort of self-contained. And here very soon, if you look at the new CAFE standards, there's going to be some very serious changes as far as mandated efficiency. to the point of the average miles per gallon is eventually the goal. The mandated goal of miles per gallon will be 55 miles per gallon as you're running on gasoline, or 55 miles per gallon total. Because with the electrics, it's an equation. We are equating the dollar per mile efficiency as it would relate to a gasoline powered car. So on a Volt, if you look at a sticker on a Volt, it'll tell you how many miles per gallon it gets. And you're like, oh, that doesn't make any sense. Well, it does have a gasoline in it. Well, don't speculate. It's because of that equation. All right. So when they say like, oh, the Volt can get 99 miles to the gallon, it means that the equivalent money you spend per mile would be the same as if your gasoline powered car got 99 miles a gallon. What does that have to do with shall not be infringes windmill? I don't know. I mean, the Volt has an induction motor, and Mike and Barking Madly are working to produce an induction alternator, an induction generator, as it were. But you may ask why an alternator versus a generator. Well, the alternator, an induction alternator, doesn't have any sort of sliding friction parts. Like you got a generator and you need brushes on the armature, which complete the circuit. And so whichever direction it's going, it starts making power. Now on your alternator, it's not just pushing the power in one direction. It's shaking the electrons back and forth. So Mike, as you're spinning your platter and you're measuring this amperage or this voltage, you're measuring how quickly, that looks bad, you're measuring how quickly the electrons are moving back and forth. Now, if you want to make that power in a usable fashion, then you need to have what is referred to as a rectifier system, which is a diode. What a diode will do for you is, instead of allowing the electrons to go that way and then back again, it'll go that way, and because you have the diode there, they won't be able to come back. It can pass through the diode, it won't be able to come back. And on an alternator, that system is called a rectifier bridge, also known as a diode trio. The reason why it's a diode trio is because there are 3 poles inside the alternator, so trio, 3. And 3-phase just happens to be the most efficient way of producing certain voltages. What Bison Hawk showed in his video is how an AC motor works when you put in 12 volts. It uses capacitors and it keeps it pushing. But now, as Daddy Yoka commented, whenever you do install a capacitor like that to get a motor to push, it's very important that you use the correct size. Now, here's the interesting part. You can change the sizes and put additional capacitors or less capacitors in it in order to increase the speed, decrease the speed, and that's how you get different speeds on your ceiling fan. How about that? Imagine that. The other way to do it is also to engage or disengage various poles in a multiple poled AC motor. So if you say had 8 poles on your AC motor and you're using it as a fan, you hit the button once, it has all 8 poles energized, you hit the button again, it goes down to 6, hit the button again, it goes down to 4. Enough to make it turn, and but yet not so much that it's not making the power steady. Still with me? I want to put a quick aside in. I didn't say anything to this point, and the reason why I'm saying it now is because the last video that you put up, Mike, you kind of tossed the whole thing aside, and I don't want to see that happen. Because I think the most important prep is the prep that happens up here. You're going to run out of resources. You're going to need to adapt resources in any disaster. The greatest preparation is a survival mentality, being able to establish the logic and having multi uses and multiple processes. You can store up all the food you want, man, but it wouldn't be enough. That's why I'm always thinking, survivalist first. So that's that. The final thing Bison Hawk briefly touched at it had to do with the turns of the motor. The windings around the coil. Now remember, I was talking about the electrons going back and forth, right? Well, the more turns you have going around it, believe it or not, the slower the magnet will be going across the length of that wire. Because imagine it as a single length of wire. If you have 10 feet of wire wrapped around a coil, the electrons still need to move those 10 feet. And the magnet is going across that wire at a very set rate. Imagine the exact same rate now of magnet with only 3 windings. The electrons move much faster. The faster the electrons move with the same voltage is actually an increase. Well, the faster the electrons move with the same load will be an increase in wattage. So on the same circuit where you have a light bulb, you can pump up the wattage of your output through the windings. Anyway, y'all keep up with your project. It's very awesome. It's very awesome to watch you guys do this. And when I'm gonna be honest, when I saw Bison Hawk's video and in the little thumbnail, I saw the sine and cosine there, and I was like, oh, this is gonna get interesting. Because we've got a motor position sensor that all-in-one sensor. It has a sine and a cosine and a Hall effect all in one single sensor. So it ends up with the thing looks almost like a stranded DNA with the signal it puts out. And by that we know exactly how fast the motor's turning and exactly what position the motor is in. And it's important. Trust me, it's important. When you have a 15 kilowatt motor, you need to know where it's going. A 15 kilowatt motor that puts out 45 foot-pounds at 1 RPM, and that's the small one. Any hoozle. Enjoy, and hopefully this video will spur Shall Not Be in French to make some more videos, man. Y'all take care. We'll see you.